Hi everyone. In this video, I would like to go over the use of chi-square. And let's assume that we have this issue here. We have you as a researcher, you plan to ask doctors whether they prefer Cerner, Epic, or they are indifferent about selecting an electronic health record system in their hospital system. So they want you as a researcher to formulate hypotheses for a chi-square test and also the way the variable will be created and pretend that you have administered the survey. So this is kind of in order to test the hypothesis, and you now have collected the data. So this is the data that I have just made up. So we have Cerner, Epic, and indifferent, and we have the different employees. In other words, they are the doctors. We have around 30, and those are the choices. So now they want us, or this issue or this problem, they want us to include the hypothesis. So we included the hypothesis here, data table, we already have it here, formulate necessary for the chi-square calculations, and they want us to make a decision based on the findings and include recommendation to the hospital. So we have the data, we have the function here or the formula for calculating the chi-square, and the hypothesis in general. So if we have only one categorical variable and we have three options and we want to know whether there is so what we need to for this chi-square problem is to know is whether the actual selections for Cerner, Epic, and indifferent for those choices are different from the expected. So the expected or the null hypothesis is that there is no significant difference between those three choices. So they are basically equal to each other, right? So we have 30 employees. So the expected or the null hypothesis is telling us that 10 people will select Cerner from those 30, will select Cerner, 10 people will select Epic, and 10 will be indifferent. So this is where we say the null hypothesis, there is no significant difference between doctors' preferences in terms of Cerner, Epic, and indifferent for the electronic health record system. The alternative hypothesis, on the other hand, it assumes that there is a significant difference between those three choices, right? So let's test this, and we are going to select the significance level of 0.05 or 5% in order to reject the null hypothesis. So let's calculate this one using Microsoft Excel. So to do that, I will go to Insert, and then I'll go to Pivot Tables, and I'll say from range. So I want to put my pivot table here. So I'll select it to be here and model there. All right, so what I will do is I will select, since here I have zeros and ones, in other words, if I sum, it will basically tell me how many people selected Cerner, how many people selected Epic. So now I'm using the sum. And if I have text here, then I might use count, but you get the idea. We need to make sure that we are calculating the number of employees that said they want Cerner, and the number of employees that wanted Epic, and the number of employees that they said they are indifferent. So this calculates it for us very clearly. So for us here, we want to see the total. So the total would be the sum of those guys. So it's 30. So this one is the actual. So that's the actual data. Now let's calculate or put the expected. So for the expected, I'll just do this guy here. It has the labels for me. So the expected here, again, when we said this is the actual, the expected for the null hypothesis that the choices, they are going to be equal. So 10 people will say Cerner, 10 people will say Epic, and 10 people will be indifferent. And that will give us basically 30, right? All right, so now let's use, we want to calculate the chi-square. So that's the chi-square is what equal. And we are going to insert this formula. So for this one, what I will need to do is I will say, so the actual, instead of selecting, I will just put P. There are some issues sometimes with the absolute versus the relative type of cell that you select. So I will just select P. In this case is P3 minus this guy raised to the power of 2 divided by expected, right? So this is basically the function. And I'm going to also add, or we can actually do this. Let me see. So that's plus. So in order to make it easier, what we can do actually is to include this function here, to put it here. That way, it can actually calculate it for us. And the chi-square is basically going to be the sum of those, sum of that. So this will be our chi-square. Now let's calculate the p-value. So for the p-value, I need to use the function where I will type chi and then distribution right. This guy. So now it's asking me for chi, which is this number, the x, and then the degree of freedom. So the degree of freedom, how many options did we have? -1. So we have option 1, 2, 3. -1 will be 2, right? So the degree of freedom is 2 in this case, and then enter. So this is our p-value. So again, remember the rule of thumb that we learned in our middle school when our math teacher told us that if the p is low, the null must go. So again, the p is lower than 0.05. So that means the null must go and the alternative will actually be supported, right? So that means there is a significant difference between those three choices. So our decision here, we say that yes, there is a significant difference, and the alternative hypothesis is supported. And the recommendation here is actually the sum or the Cerner has won, and it is significantly different from the other two options. So that's all that we can say. Here we can say Cerner won as a choice for AHR selection. So I hope this helps, and all the best to you, and thank you.